ተማሪዎች እንዴት ነው ሳምንቱ እንዴት አለፈ ትምርት ላይ እንደሆናችሁ ምንም ጥርጥር የለንም ስለዚህ በርቱ በደንብ ለማንበብ መሞከር ይኖርባችኋል ባለፈው ሳምንት የተለያዩ ነገሮችን ለማየት ሞክረናል ስለ ሜታሊክ ቦንዲንግ እንዲሁም ስለ ኢንተርሞሌኩላር ፎርስ በተጨማሪም ስለ ኬሚካል ቦንዲንግ ቲዮሪ አንደኛውን ቫለንስ ቦንድ ቲዮሪን ለማየት ሞክረናል ማለት ነው ስለዚህ ወደ ዛሬው ትምርት ለመሄድ ዝግጁ ናችሁ ስለዚህ እንቀጥል okay today we are going to discuss about hybridization the second types of chemical bonding theory that is molecular orbital theory and finally types of crystal okay let's start hybridization students what is hybridization what mean by hybridization means okay nice hybridization is the mixing up of two or more different atomic orbitals of the same atom. The mixing up of two or more different atomic orbitals of the same atom is known as hybridization. In hybridization, different atomic orbitals are mixed together. Finally, it produces what? Hybrid orbital. The number of hybrid orbital, it depends on the number of atomic orbital. That means 2 atomic orbital produces 2 hybrid orbitals. 3 atomic orbital produces 3 hybrid orbitals. 4 atomic orbital produces 4 hybrid orbitals. 5 atomic orbital produces 5 hybrid orbitals and so on. Therefore, the number of hybrid orbital depends on what? Depends on the number of atomic orbitals. That means 1s and 1p mixed together, sp can be formed. But the number of sp is 2. Again, 1s and 2p mixed together finally produces sp2. How many sp2? 3 sp2. Why 3 sp2? Because 1s and 2p. Again, 1s mixed with 3p, how many atomic orbital? 4 atomic orbital. Because 1s and 3p, total 4 atomic orbital, finally produces sp3. sp3, this one. How many sp3 can be formed? 4. Because the number of hybrid orbital depends on the number of atomic orbital. 1s, 3p, it produces sp3. How many sp3? 4 sp3. Again, 1s, 3p, and 1d, it produces sp3d. Please, student, sp3d is not atomic orbital. sp3d is hybrid orbital. How many sp3d can be formed? 5. Why? Because 5 atomic orbitals can be mixed together. 1s, 3p, and 1d finally produces sp3d. Similarly, sp3d2. Simply, hybridization is the mixing up of 2 or more different atomic orbitals of the same atom. Again, the number of hybrid orbital depends on the number of atomic orbital. Different types of hybrid orbital can be formed. The common hybrid orbital is sp, sp2, sp3, sp3d, and what? sp3d2. This is all about in hybridization. The other one is molecular orbital theory. Molecular orbital theory, this is the second types of chemical bonding theory. Remember for last time discussion. And last time discuss about valence bond theory, which is VBT. In today's molecular orbital theory, the second chemical bonding theories. Valence bond theory concerned the half field of different atomic orbital mixed together, s and p, p and p, and so on. This is the second one, molecular orbital theory. Molecular orbital theory, as atoms approach each other and their atomic orbitals overlap, between different atomic orbitals overlap, molecular orbitals are formed because of overlap. The 2 types of molecular orbitals are bonding and anti-bonding molecular orbitals. For example, in H2, let's take the diagrams of H2. You know H2, hydrogen molecule. Look, diagrammatic forms of H2. Assume this is energy. This is energy. Energy diagram of H2. Because in molecular orbital theory, two types of molecular orbitals can be formed. One is bonding molecular orbital. The other one is anti-bonding molecular orbital. Look the difference between bonding and anti-bonding by using of a diagram of what? H2, hydrogen molecule. Look, hydrogen molecule. In H2, this is energy. This one again energy. This is atomic orbital. Again, this one is atomic orbital. Look, this is one is bonding. The other one is anti-bonding. This is one electron. This is one electron. Why one electron? Because hydrogen with another hydrogen, let's take hydrogen is 1s1. The shape of the last subshell of hydrogen is what? S. What is the shape of S? Spherical. Another hydrogen, 1s1. This is one electron. This one. Another one electron. This one. This two is what? Atomic orbital. How many atomic orbital? 2 atomic orbital. 1, 2. Now, this two is produces this one. This is sigma 1s. Remember for last time discussion. S atomic orbital overlap with S atomic orbital always produces sigma bonds. S always produces sigma bonds. Therefore, S with S. Why S? Because this is the outermost shell of hydrogen, S. Another outermost shell of hydrogen is S. S with S, always sigma bond can be formed. But how many electrons? 2. 1 is up, 2 is down. Therefore, this is 2. This is what? Molecular orbital. What about this one? Again, molecular orbital. The difference is this one is anti-bonding molecular orbital. Anti-bonding. This is the anti-bonding. This one is bonding. Bonding molecular orbital. How many atomic orbital? 2 atomic orbital. 2 atomic orbital produces how many molecular orbital? 2 molecular orbital. One is bonding molecular orbital, this one. The other one is anti-bonding molecular orbital, this one. Bonding molecular orbital maximum contains 2 electrons. Again, anti-bonding molecular orbital maximum contains 2 electrons. The number of electrons that contain is the same. Therefore, in bonding molecular orbital contains 2. This is bonding molecular orbital. This one is anti-bonding molecular orbital. Look, this one. Bonding molecular orbital and anti-bonding molecular orbitals. In bonding molecular orbital, have a region of high electron charge density between the 2 nuclei. Between the 2 nuclei means, for example, look, this is the shape of S. This is the shape of another S. S, 1 electron, another S again, 1 electron. This is overlap. Between these 2 overlap, this one is can be formed. How many electrons here? 2. The 2 electrons are between the 2 nuclei. In this case, these types of overlap, sigma, how many electrons are present here? 2. In this case, the 2 electrons are present between the 2 nuclei. The 2 electrons are present between the 2 nuclei. Therefore, have a region of high electron charge density. Yes, because the 2 electrons are present in the nucleus, between the nucleus. Present the charge of the density between the 2 nuclei. Again, denoted by sigma or pi. Yes, because this is represented by sigma. Sigma or pi. Pi means it forms by using of a parallel overlap or side to side or lateral can be formed pi. Sigma and pi is for bonding molecular orbital. Stable, yes, because this, look, this diagram for H2. This is a higher energy level. This position is the lower energy level. Always the lower energy level is stable. The energy increases, the stability will be decreases. The energy decreases, the stability becomes increases. Therefore, bonding molecular orbital, it is stable. Yes, why stable? Because exists at lower energy level. exist at lower energy level? Yes. Look, this diagram. Bonding exists at higher energy level or at lower energy level? At lower energy level. Therefore, bonding molecular orbital exists at lower energy level. The other one is anti-bonding. Have a region of zero electron charge density between the two nuclei. Yes, because the two electrons are far away from the two nuclei. The two electrons are present away from the nucleus. But in the case of bonding, the two electrons are present between the nuclei. This is the difference between bonding molecular orbital and anti-bonding molecular orbital. The other one, denoted by sigma star. A star indicates this position, anti-bonding, higher energy level. Look, in bonding molecular orbital, denoted by sigma. This one is sigma star. This is denoted by pi. This one is pi star. A star means in higher energy level. Away from the region between the two nuclei, yes, because the two electrons are away from the two regions. Unstable. The previous one is stable. This is unstable. Why unstable? Why unstable? Because it exists higher energy level. Exists at higher energy level. This is the difference between the two types of molecular orbital theory. The other one is the electron configurations of diatomic species. You know, diatomic. Atom is atom. Di means two. The electron configurations of diatomic species, not the electron configurations of atoms. This is the electron configurations of diatomic species. The order of energy for molecular orbital has been determined mainly from spectroscopic data. There are two types of electron configuration ways. The first one, in simple homonuclear diatomic species or heteronuclear diatomic species, not only for homo. Again, for hetero, it depends on what? The total number of electrons. This is not only for homo. Again, hetero, again, it is possible. Hetero and what? Homo and hetero is possible. For hetero and for homo, diatomic species, you know, dies too. It depends on the electron configuration, depends on the total number of electrons. That means the total number of electrons, 14 or less, uses this configuration. The total number of electron greater than 40, the order is this one. Two types of order. Two types of order. One is total number of electron less than or equals to 40. Less than or equals to 40, the order is this one. Sigma 1s, sigma star 1s. Sigma 2s, sigma star 2s. Pi 2p y, pi 2p z. And sigma 2p x. This is molecular orbital. This is molecular orbital, but the antibonding molecular orbital. Each molecular orbital maximum contains 2 electrons. Therefore, 1, 2, 3, 4, 5, 6, 7. Each contains 2. Total number of electrons is 40. Up to 40, this one is possible. By the way, these two are known as what? Pi 2py and pi 2pz. These two pi 2p and pi 2pz is what? Yes? Degenerate orbitals. These two are degenerate orbitals. Students, what mean by degenerate orbitals? What mean by degenerate orbitals? Yes? Nice. Degenerate orbitals means the same energy level. The same energy level. That means pi 2py and pi 2pz, the same energy level. But sigma 1s and sigma star 1s, not the same energy level. Sigma star 1s and sigma 2s, not the same energy level. These two are not degenerate orbitals. These two are degenerate orbitals. For degenerate orbital, users apply which rule? Yes, Hund's rule. For degenerate orbital, apply the Hund's rule. You know, in chapter 2. Therefore, this is sigma 2px. The other one is total number of electrons is greater than 40. Total number of electrons is greater than 40. The order is, look, total number of electrons is greater than 40. The order is sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, sigma 2px, pi 2py, pi 2pz, this is degenerate, pi star 2py, pi star 2pz, and finally sigma 2px star. This is for total number of electrons is greater than 40. By the way, each molecular orbital maximum contains 2 electrons. Look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 molecular orbital. Maximum contains how many electrons? 20 electrons is possible from this electron configuration. Therefore, this is the electron configurations of diatomic species. The first one is less than or equals to 40. The other one is greater than 40. Therefore, this is the two types of electron configuration. The other point is bond order. Bond order. In molecular orbital electron configuration, the other point is bond order. It refers to the number of bonds that exist between two atoms. Because between two atoms, a single bond can be formed. A double bond can be formed. A triple bond can be formed. This is known as bond order. Therefore, this bond order refers to the number of bonds that exist between two atoms. It is a measure of stability. Yes, a measure of stability. What does that mean? A measure of stability means a single bond converted into double bond, or double bond converted into triple bond, the stability increases. Bond order can be determined by half of Nb minus Na. Nb means number of bonding electrons. Na means number of anti-bonding electrons. If the bond order increases, then the stability and the bond energy increases. Bond energy means what? The amount of energy required to break that bond. But the bond length will be decreases. Bond length means between atom with atom. Single bond greater than double bond is greater than triple bond in bond length. The other point is magnetic properties. There are two types of magnetic properties. One is paramagnetic, the other one is diamagnetic species. By the way, paramagnetic means when we write the molecular orbital electron configuration, at least one free electron is present, that species is paramagnetic. Paramagnetic means it contains at least one free electrons, one unpaired electrons. Paramagnetic species attracted by external magnetic field. The other one is diamagnetic species. Diamagnetic species means when we write the electron configuration, the molecular orbital electron configuration, all the electrons are paired. All the electrons are paired is diamagnetic species. For example, H2. H2 is hydrogen molecule. The first one is total number of electron. What is the total number of electron? One hydrogen, one electron, another hydrogen, one electron, 1 plus 1, 2. 2 is total number of electron. The other one is the molecular orbital electron configuration. Sigma 1s2. Sigma 1s2. For example, H2 sigma 1s2, because total number of electron is 2. This is the molecular orbital electron configurations of H2. Students, this is paramagnetic or diamagnetic? Diamagnetic because this is paired. Paired is diamagnetic, therefore this is diamagnetic. The other one is what? bond order. Look, bond order. Bond order is equals to, you know the formula, half of NB minus NA, which means half of NB. What is B? Bonding electron. How many bonding electron? This is bonding or anti-bonding? Because there is no star is bonding. The bonding electron is 2. 2 minus anti-bonding star. Is there any star? No. Therefore, 0. 2 minus 0. 2. 2 divided by 2. 1. Therefore, the bond order is 1. What does that mean the bond order is 1? 1 means it is single bond. Between hydrogen and hydrogen, single bond can be formed. Therefore, bond order determine is it single bond, double bond, or triple bond? Sometimes represented by dot, dot, and so on. Example 2, C2. C2 is carbon, 2 carbon. You know carbon is atomic number? 6. 6 plus 6, 12. 12 indicates 2 carbon. 6 plus 6, 12. The electron configuration is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, pi 2p, pi 2p. Why pi 2p? One is for x, the other one is for y, or the other one is for z, and so on. Look, 1, 2, 3, 4, 5, 6. 6 means 12. Look, all the electrons are paired, 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 paired. All are paired. This is diamagnetic. The previous one again, diamagnetic, because it is paired. Bond order. Bond order is equals to half of number of bonding. Look, number of bonding electron. 2, 2, 2, 2, 8. Minus anti-bonding here, 2. Anti-bonding again, 2. 2 plus 2, 4. 8 minus 4, 4. Divided by 2, 2. Therefore, the bond order is 2. That means carbon with carbon, a double bond. N2. Total number of electrons is 40. Why? Because nitrogen is 7. 7 plus 7. 7 plus 7 is 14. This is the molecular orbital electron configuration. Sigma 1s2, sigma star 1s2. Remember, there are two types of rule. One, total number of electrons less than or equals to 40. The order is this one. Total number of electrons, 1, 2, 3, 4, 5, 6, 7. 7 means 14. All electrons are paired. Because of that, again diamagnetic. Next, bond order. Bond order is equals to half of 10 minus 4. Why 10? 1, 2, this one, 3, 4, 5 times 2, 10. This is 10. Minus 4 means a star. 2, another star, 2. 2 plus 2, 4. 10 minus 4, 6. Divided by 2, 3. What does that mean? 3 indicates. Yes? A triple bonds. Therefore, nitrogen forms a triple bonds like this. Similarly, O2, oxygen. Oxygen, 8 plus 8, 16. Oxygen is atomic number 8. 2 oxygen is 16. In this case, the order is not similar to this one because total number of electrons greater than 40, this is the correct order. Look, 1, 2, 3, 4, 5, 6, 7. 7 means 14. How many electrons are remain? 2 electrons. But the 2 electrons are present pi star 2p, another pi star 2p. Pi star 2p and pi star 2p, another pi star. Pi 2p, pi star. Pi 2p and another pi 2p. These two are degenerate. Again, these two are degenerate. Degenerate means what? The same energy level. Because of the same energy level, these 2 electrons are uses 1, 1, not 2, 0. For degenerate orbitals, electrons are shared equally. 1, 1. Because of 1, 1, this is paramagnetic. Paramagnetic means a species. That means one of the molecular orbital, the bonding or the anti-bonding, it contains one free electron is paramagnetic. Therefore, this species, it is paramagnetic. Why paramagnetic? Because one is free, one is not paired. This is paramagnetic. The other one is bond order. Bond order is what? The formula half of Nb minus Na. Nb what? Bonding electron. Bonding 2, 2, 4, 2 plus 2, 4, plus 2, 6 plus 2, 8 plus 2, 10. Minus 6. 6 means 2 electrons here, another 2 electrons here. 1, 1 is 2. Total number of electrons is 6. 10 minus 6, 4. Divided by 2, 2. 2 means oxygen indicates a double bond. By the way, N2 and O2. N2, triple bond. O2, double bond. Which one is requires large amount of energy to break a bond? N with N or O with O? N with N is difficult because of triple bond. As compared to N2 and O2, which one is more reactive? O2, because of paramagnetic species. Similarly, Cn minus. For Cn minus, look, it is a charged species. Carbon, electron is 6, plus, N means nitrogen, 7, plus, minus indicates plus. By the way, minus is gain of electrons, plus losing of electron. Carbon is 6, nitrogen is 7, minus means plus 1. Total number of electrons is how much? 14. Because of 14, it is similar to what? N2. Therefore, the molecular orbital electron configuration, the bond order, and also the magnetic property is similar to those of N2. This is for Cn minus. Finally, this is types of crystal. The last subtopic for Unit 3 is types of crystal. A crystal is a piece of solid substance. Crystal exists in the forms of solid. Crystal exists in the forms of solid substance that has a plane surface, sharp edge, and irregular geometric shapes. There are commonly 4 types of crystals. 1, ionic crystal. By the way, ionic crystal, the molecular crystal, also the other types of crystal exists in the forms of solid states. The first one is ionic crystal. The fundamental units are ions. Which ions? Cations and anions. Because there are 2 types of ions, cations and anions. The fundamental units of ionic crystals are ions, cations and anions. Consist of cations and anions held together by electrostatic attraction of opposite charge. This opposite charge is what? Cations and anions. For example, sodium chloride, potassium nitrate, calcium carbonate exist in the forms of solid. Therefore, this is ionic crystals. These ionic crystals, by the way, do not conduct electricity. Ionic crystals do not conduct electricity because cations and anions are not freely moving. The second one is molecular crystal. Molecular crystal exists in the forms of molecules. The fundamental units are molecules. Consist of atoms or molecules held together by intermolecular forces. Intermolecular force means force of attraction between species. This one is weak. Examples of molecular crystal. Sugar. You know sugar. Sugar is in the forms of solid. Students, sugar conduct electricity? No, because there is no free ions. There is no free electrons. Therefore, sugar, dry ice, you know dry ice, solid carbon dioxide, glucose, you know aspirin. You know aspirin? Aspirin? That is a common painkiller. The other name of aspirin is what? Acetyl salicylic acid. The other name of aspirin is acetyl salicylic acid. All these compounds do not conduct electricity. The other one is covalent network crystal. Covalent network crystal, the fundamental units are atoms. In covalent network crystal, for example, graphite, diamond, quartz is under covalent network crystal. One atom with another atom combined by a strong covalent bonds. Consist of atoms held together in a large network by covalent bond. One atom with another atom connected with atoms. The whole is one giant molecule, a very giant molecules. Examples of covalent network crystals, quartz, diamond, graphite, and so on. These compounds, again, do not conduct electricity except graphite. Graphites conduct electricity. Finally, metallic crystal. This is a property of metal. Metallic crystal, the fundamental units are atoms, consist of atoms held together by metallic bonding. The difference between metallic crystal with the other types of crystal, metallic crystals conduct electricity because of freely moving electrons. This is a good example for metallic crystals like copper, silver, gold, aluminum, iron, and the other metal atoms. This is the end of chapter 3. Thank you, students. Thank you, family.